students, as unfortunate as it sounds, classes had been suspended due to a typhoon. Although we are facing tough times today, I and your other teachers hope that you're doing well and safe. We do hope that this video guides you well throughout the lesson in replace of our face-to-face classes. This lesson is how to find zero or zeros of a polynomial function. Before we start, let me introduce you guys to your teachers. Firstly, this is Miss Zoe Isabel Francisco teaching you how to find the zeros of a linear equation. This is Mr. Sean Gabriel Yee teaching you guys how to find the zeros of a quadratic function. This is Miss Katrina Faith Abililia teaching you guys how to find the zeros of a cubic function. These are Miss Maxine Basigan and Miss Dorothy Yvonne Meday teaching you how to find the zeros of a quantic function. And finally, I am Miss Chelsea Lorino Palani, and this is Mr. Pierre Angelo Silang teaching you guys how to find the zeros of a quintic function. Without any further ado, let us start our discussion with Miss Zoe Isabel Francisco.
Good day, students. I'm one of your teachers, Miss Zoe. I'll be discussing and teaching you today about polynomial functions. Polynomial functions are expressions consisting of variables, coefficients, and exponents. There are many types of functions based on the degree of the polynomial, but we can't discuss all of them. You'd end up both bored and confused at the end of this video lesson. So, we will only discuss the common types of polynomial functions instead. If a polynomial function with its highest degree being 1, it is called a linear function, which is going to be our first topic. Finding zero is just another term for solve this equation. So, f of x turns into 9x minus 6 is equal to 0. Our first step to this is to transpose the whole number, which turns 9x is equal to positive 6. Now, when we transpose, the sign of the number always changes. So for example, in this equation, negative 6 transpose is positive 6 and vice versa. Our next step is to divide both sides by 9. Now, 9x over 9 are just the same thing, so they are cancelled, which then we are left with 6 over 9. Now we could leave this like this, or we could simplify them. Since the both of them they can be simplified or divisible by 3, we can divide the both of them by 3 and could turn into 2/3, which then our answer would be x is equal to 2/3. Pretty easy, right? Now, let's move on to our next example. Here, our next example is f of x is equal to 4x plus 7. Now, we are just going to do what we did with our first example. So, 4x plus 7 turns into 4x plus 7 is equal to 0. Now, our first step is always to transpose the whole number. So, this turns into 4x is equal to negative 7. Now, we divide both sides by 4. 4x over 4 is the same thing, so we cancel them, and now we are left with negative 7 over 4. They're both not really divisible by anything, so our answer will be x is equal to negative 7 over 4. Now, I'll wrap it up a bit on this last question and add a fraction to the equation. Now, our last example is f of x is equal to 1/2 x plus 4. To solve this, we must first find the LCD, also known as lowest common denominator. From what I'm seeing here, our LCD is equal to 2. Next, I will be distributing the LCD and multiply. So 2 times 1/2 x plus 4 is equal to 0 times 2. Now, we multiply. 2 times 1/2 is equal to x, and 2 times 4 is equal to 8. So plus and 8 is equal to 0 times 2 is obviously 0, so let's put 0. Now we are going to transpose. So x is equal to negative 8, and there you have it. Our final answer is x is equal to negative 8. Now that is all for the linear equation. I hope that this lesson was easy to understand and follow. Now let's move on to our next lesson.
Hello, my name is Mr. Yee. Today I'll be showing you how to look for zeros using remainder factor theorem, the press equation, and factor. But remember, when you're solving for zeros and using synthetic division, always has to be on standard form. Okay, let's take a look at this first problem. Now, as you can see, it's already on standard form. Standard form always decreasing the exponents. Okay, so it's all about trial and error when you're looking for zeros because you can't look for the exact ones. You're looking for the exact zeros, okay? So now, you're going to look for the possible zeros because it's possible. So we're going to put 6. We're going to use an equation, a solution called P over Q. So P over Q, which is the last digit, is 6 over 1. Okay. Now we'll be putting, okay? We'll be putting the factors of 6 and 1. Okay. So we'll put positive, negative 1, positive, negative 2, positive, negative 3, and positive, negative 6. Okay. Now we're putting for 1, factors of 1 is 1. There you go. Now we're going to be dividing it. Oh, don't forget to put a fraction line. Okay. We're going to be dividing it. We're going to be dividing 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 6. There you go. Always add the positive negative, okay, when you're looking for possible zeros, because you can't know which one. So we'll be using synthetic division. Just bring down. So it's going to be 1, negative 5, and 6. Okay, bring down. So first we're going to bring, so like, we're going to be trying now, okay? We're going to be doing trial and error. So let's choose on one of the possible zeros. I choose 2, positive 2. Okay, let's try 2. Now, remainder factor theorem is just like upside down radical, upside down division. So bring down 1, 2 times 1. Always bring down the first number, okay? 2 times 1 to negative 5 plus 2. This part is always added. Negative 5 plus 2, it's going to be negative 3. Negative 3 times 2, it's negative 6. 6 plus negative 6 is 0. Already found our first zero, which is 2. Now, we're going to find 2 zeros because when you're looking, you're going to know how many zeros you're going to find is by looking at the highest exponent, which is 2. So we're looking for 2. So we're going to be using factoring. So bring down 1, just x, negative 3 equals 0. Negative 3 is negative 3. Oh my god, okay, negative 3. Now we're going to be transposing. We're going to be transposing negative 3 to the 0. So x equals 3, positive, because when you're transposing, you're always changing the sign. Just switch it right over here. We're going to be changing the sign, so I just put positive. So this is your other 0. Here you go. Very easy. Our zeros are 2 and 3. Nice. Okay, let's just erase this. Again, look for the possible zeros. Let's do it here. So P over Q is mean negative 3. Oh, I forgot. Don't add any signs when you're looking for the possible zeros. Like on this one. This one, don't look for. Okay, now I'm going to put 2. Okay, now look for the factors. Now do divide. Always put the fraction line. Okay, don't forget the fraction line. So copy the top one because it's 1. It's always going to be the same one. Okay, positive negative 1, positive negative 3, and add 1 divided by 2. That's going to be 1/2 and 3 over 2. Positive negative 3 over 2. So 1/2 and 3 over 2 went 1 and 3. Okay. So now let's use synthetic division. 2, 1, negative 3. Let's try 1. And remember, this are choices. Okay. 1. Bring down 2. 1 times 2 is 2. 1 plus 2 is 3. 3 plus 1 is 3, which is 0. There you go, you found it. Found our first 0. It's 1. Now factoring. It's going to be 2x plus 3 equals 0. Now we're going to do transposing. So it's going to be 2x equals negative 3. Now we're going to isolate to an x. So we're going to divide both sides by 2. Cancel, cancel. There you go. Our last 0 is negative 3 over 2. There you go. So our zeros for this one is positive 1 and negative 3 over 2. There you go. Now, next question, or next problem. Okay. Hi. Now, next problem. Negative 2x squared plus 2. Hang on. Guys, might not read it. I can't read it. There you go. I think that's pretty good. Okay. Now, as you can see, it's not in standard form. So first, let's just try to look for the possible zeros, okay? So our possible, let's use, again, P over Q. So that's positive 2 and negative 2. Don't put signs. Now, you put positive, negative 1. Now, fraction, align. and divide. And 1/2. Now, 2 over 2, 2 divided by 2 is basically 1. Now, let's solve it using synthetic division. Now again, it's not in standard form, so what you're going to do is add a 0. Bring down negative 2, and 0, and 2. Now, let's choose from our possible zeros. Let's try 1. 1. Bring down negative 2, the first number, always. 1 times negative 2 is negative 2. 1 plus negative 2, I mean 0 plus negative 2 is negative 2. Negative 2 times 1 is negative 2. 2 plus negative 2, 0. Okay, now, factor. Or, if you don't like factoring, just look for it again. Look for another one. So look for the other 0, trial and error. If you don't want to use factoring, let's try negative 1. Negative 1. Okay, so let's bring it negative 2, 0, and 2. Okay, bring down negative 2. Always. Negative 1 times negative 2 is positive 2. Bring down negative 1 times 2, negative 2, which brings us to 0. Now, we found our zeros. Negative 1 and 1. When looking for the final answer, we can do a shortcut, or writing the final answer, we can do a shortcut. We can do positive negative 1. Okay? Positive negative 1. Since there's 2 1s, but same sign. I mean different signs. So, there you go. Thank you for watching.
Good day everyone, I am Katrina Faith Abililia and I'll be teaching you the cubic functions and how to find its zeros. Cubic functions are functions with the highest degree of 3. Let's start with our first example, which is f of x is equal to x cubed plus x squared minus 10x plus 8 is equals to 0. To find its zeros, we could use a rational root theorem, which is eliminate any possible roots or zeros that could be used. The formula is p over q. P is our constant term, q is our leading coefficient. So in this example, our p is 8, q is 1. Then we'll be writing their factors. The factors of 8 are positive negative 1, positive negative 2, positive negative 4, and positive negative 8. Then the factors of 1 are positive negative 1. Now, we will multiply denominator to the numerator. But since our denominator is positive negative 1, our example and our possible zeros are this. Now we write down our example equation. 1, 1, negative 10, and 8. Get the 0 from the box, and trial and error. Let's start with positive 1. Bring down 1. 1 times 1 is equal to 1. 1 plus 1 is equal to 2. Then 1. And then 2 times 1 is equal to 2. Negative 10 plus 2 is equals to negative 8. Negative 8 times 1 is equals to negative 8 again. 8 plus negative 8 is equals to 0. When the number is equal to 0 at the end, that means 1 here is one of our zeros. Now we can continue and repeat the method. Let's try negative 4. Bring down 1. 1 times negative 4 is negative 4. 2 plus negative 4 is equals to negative 2. Negative 2 times negative 4 is equals to positive 8. That makes 4, or negative 4 rather, one of our zeros. Now we can continue this method, but since there are 2 numbers left, we can factor them. And this is x minus 2. So our zeros, for example number 1, is x equals 1, x equals negative 4, x equals 2. It is 2 now because we transposed it. But if we write it in factored form, it will look like x minus 1, x plus 4, and x minus 2. Same to the one we did at the end of the synthetic division. Now let's try a second example. For a second example, it is f of x is equal to x cubed plus, negative 3x squared, negative 4x plus 12 equals to 0. Now let's do again the rational root theorem, which is p over q. P being our constant term, q being the leading coefficient, which is 1. Now we write the factors. Positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and lastly positive negative 12. And the factors of 1, which is positive negative 1. Since this is, again, positive negative 1, the denominator, this is our possible zeros. Now let's proceed to synthetic division. Let's start with 2. 1, minus 3, negative 4, 12. This is our example equation. Bring down 1. 1 times 2 is equals to 2. Negative 3 plus 2 is equals to negative 1. Negative 1 times 2 is equals to negative 2. Negative 4 plus negative 2 is equals to negative 6. Negative 6 times 2 is equals to negative 12. That makes 2 one of our zeros. Now we repeat the method. Let's try negative 2. Bring down 1. 1 times negative 2 is negative 2. Negative 1 plus negative 2 is equals to negative 3. Negative 3. Negative 3 times negative 2 is equals to 6. That makes negative 2 one of our zeros as well. Now we can repeat the method again, but since these are 2 terms left, we can factor it. This is equal to x minus 3. So our zeros for example number 2 is 2, negative 2, and positive 3. Since this is again transposed, so it becomes x equals to 3. In factored form, it will look like this. X minus 2, x positive 2, and x minus 3. Let's try another example. For our third and final example, our equation is f of x is equal to x cubed plus 2x squared minus 20x plus 24 is equal to 0. Again, let's do the rational root theorem, which is p over q, p being our constant term, which is 24, and our leading coefficient, which is 1. Let's write its factors. Factors of 24 is positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 8, and positive negative 12. And the factors of 1, which is positive negative 1. Since again this is just 1 times 1, denominator to numerator, this is our possible zeros. Now let's use the synthetic division again. We write the equation. In this case we have 1, 2, negative 20, and 24. Let's take a root and test it here. Let's try negative 6. Bring down 1 times negative 6 is equals to negative 6. 2 plus negative 6 is equal to negative 4. Negative 4 times negative 6 is equals to 24, positive 24. And then negative 20 plus 24 is equals to 4. 4 times negative 6 is equal to negative 24. That equals to 0, therefore negative 6 is one of our zeros. Now we repeat this method. Let's try 2. Negative 2. Bring down 1 times negative 2 is equals to negative 2. Negative 4 plus negative 2 is equals to negative 6. Now, negative 6 times negative 2 is equal to positive 12. It is not equal to 0, therefore negative 2 is not a 0. How about let's try positive 2. Bring down 1 times 2 is equals to 2. Negative 4 plus 2 is equals to negative 2. Negative 2 times 2 is equals to negative 4. That makes positive 2 one of our zeros as well. Now we can try and continue this method, but since there are 2 terms again, we can't factor them. But I'll show you what it would look like if we continue to factor them. Let's try 2. Again, bring down 1 times 2 is equal to negative 2 plus 2 is equal to 0. So that's our 3 zeros. So if we rewrite it, it's negative 6 and 2. Negative 6, 2, and 2. But we can also write negative 6 to multiplicity of 2, since 2 is recurring. Now, if we write it on the factored form, it will look like x minus 2, x minus 2, and then x plus 6. That is all. Thank you. I hope you learned something today. See you next time.
Hello lovely students, I'm Miss Pasigan and I'm going to teach you how to find the zero of a quadratic equation using synthetic division. First, Let's check the standard form to see if there's a missing term. 4, 3, 2, and 1. We don't have any missing terms. If the standard form has a missing term or terms, always add 0 to the term or terms that is missing. Next, let's find all the roots using P and Q. P is for the constant of the polynomial, and Q is for the leading coefficient of the polynomial. So our P is negative 12, and our Q is positive 2. Let's find all the numbers that can be divided to these two numbers. What are the factors of negative 12? Positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive negative 12. So, 6 times 2 is equals to 12, and 4 times 3 is equals to 12. What are the factors of positive 2? Positive negative 1 and positive negative 2. So, the possible rational zeros are positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 12, positive negative 1 half, and positive negative 3 halves. After this, let's start the synthetic division. First, write down all the coefficients of the polynomial. Positive 2, positive 5, negative 5, negative 20, and negative 12. Let's try negative 2 and see if it works. Bring down 2. Negative 2 times 2 is equals to negative 4. 5 plus negative 4 is equals to 1. Negative 2 times 1 is equals to negative 2. Negative 5 plus negative 2 is equals to negative 7. Negative 7 times negative 2 is equals to 14. Negative 20 plus positive 14 is equals to negative 6. Negative 6 times negative 2 is equals to 12. Positive 12. Negative 12 plus positive 12 is equals to 0. Since the last term is equals to 0, so negative 2 is a root. Next, let's use positive 2. Bring down 2. 2 times 2 is equals to 4. 4 plus 1 is equals to 5. 5 times 2 is equals to 10. Negative 7 plus positive 10 is equals to 3. 3 times 2 is equals to 6. Negative 6 plus positive 6 is equals to 0. Again, since the last term is equals to 0, so positive 2 is a root. Let's do it again. Let's use positive 1. Bring down 2. 2 times 1 is equals to 2. 5 plus 2 is equals to 7. And 7 times 1 is equals to 7. 7 plus 3 is equals to 10. Since the last term is not equals to 0, positive 1 is not a root. Oh wait, when you're doing this trial and error, you need to be patient. Because just like this root, the last term is not equal to 0. So you need to try again. Let's try negative 1. Bring down 2. Negative 1 times positive 2 is equals to negative 2. 5 plus negative 2 is equals to positive 3. 3 times negative 1 is equals to negative 3. So, negative 1 is a root. So, the factored form are 2x plus 3, x plus 2, x minus 2, and x plus 1. Let's list down the zeros by changing the signs. Positive negative 2, negative 1, and negative 3 over 2. So, positive negative 2, negative 1, and negative 3 over 2 is the zeros of this polynomial. You can also get the zeros by getting the roots and change the signs. And that is how you find the zero of a quartic equation using synthetic division. The next quartic equation will be tackled by Miss Meday. Again, I'm Miss Pasigan and I hope this video helped. And as always, happy studying!
Thank you, Ms. Pasigan, for the lovely introduction. Hello, my dear students. I'm Dorothy Miday of Brother Arcadius. Today, you will learn about the rational roots theorem of quartic equation. Okay, we will start by x raised to 4 plus 2x cubed minus 2x plus 15 minus 16 squared equals 0. Now, we will transform this into a standard form first. Okay, x raised to 4 plus 2x cubed minus 2x squared minus 2x plus 15. Now, our P over Q is equals to 15 over 1. Firstly, we should find the numbers that when you divide it, you got 15 and 1. Our dividers for 15 is positive negative 1, positive negative 3, positive negative 5, and positive negative 15. And of course, the only number for 1 is positive negative 1. Then we will divide this all to 1. Now, let's use the synthetic method. Just copy this off. And firstly, in our possible zeros, we'll use negative 5. So bring down 1. 1 times negative 5 is equals to negative 5. 2 minus negative 5 is equals to negative 3. Negative 3 times negative 5 is equals to 15. Negative 16 minus 15 is equals to negative 1. Negative 1 times negative 5 is equals to 5. Negative 2 minus 5 is equals to 3. 3 times negative 5 is equals to negative 15. 15 minus negative 15 is 0. So second, we're gonna use for our possible zeros is 3. Again, bring down 1. So 1 times 3 is equals to 3. Negative 3 minus negative 3 is equals to 0. 0 times 3 is equals to 0. Negative 1 minus 0 is equals to negative 1. Negative 1 times 3 is equals to negative 3. Positive 3 minus negative 3 is equals to 0. And lastly, we're gonna use positive 1. Again, bring down 1. 1 times 1 is equals to 1. 0 minus 1 is equals to 1. 1 times 1 again is equals to 1. Negative 1 minus 1 is equals to 0. Now, this is our factored form. X plus 5, x minus 3, x minus 1, and x plus 1. And our zeros is positive negative 1 or 1 multiplicity to 1 and 3 minus negative 5. And that is all for our discussion. I'm Dorothy Miday of Temperature Arcadius, and I hope you learned something today. Thank you!
Am I audible? Okay. Good morning, class. I am Pierangelo Visilan, and I'm going to teach you about quintic functions and how to find its zeros when the polynomial has a multiplicity and a fraction. So, our problem here is 2x raised to 5 minus x raised to 4 minus 25x cubed minus 20x squared plus 28x plus 16. The other teachers have probably taught you how to solve or how to do the basic stuffs like finding the possible zeros and finding the zeros. So let's make it quick. 16 over 2 equal to factors of 16 is positive negative 1, positive negative 2, positive negative 4, positive negative 8, and positive negative 16. On the other hand, 2 has only positive negative 1 and positive negative 2. We'll divide both of these and we will have our possible zeros. Our possible zeros are positive negative 1, positive negative 2, positive negative 4, positive negative 8, positive negative 16, and positive negative 1/2. We'll now test their legitimacy if they are really the zeros of p of x. First, we will test positive negative 1. We will use synthetic division to prove if this is actually a zero of p of x. So, bring down 2. 2 times 1 is 2. Negative 1 plus 2 is 1. 1 times 1 is equal to 1. Negative 25 plus 1 is negative 24. Negative 24 times 1 is negative 24. Negative 20 minus 24 is equal to negative 44. Negative 44 times 1 is equal to negative 44. 28 minus 44 is equal to negative 16. Negative 16 times 1 is negative 16. And 16 minus 16 is equal to 0. So 1, positive 1, is one of our zeros. We will just continue this using the first equation. So let's try negative 2. So bring down 2. 2 times negative 2 is negative 4. 1 minus 4 is negative 3. Negative 3 times negative 2 is 6. Negative 24 plus 6 is negative 18. Negative 18 times 2 is 36. Negative 44 plus 36 is negative 8. Negative 8 times negative 2 is 16. Negative 16 plus 16 is 0. Therefore, negative 2 is also one of our zeros. So let's try negative 3. I bring down 2. 2 times negative 3 is negative 6. Negative 3 plus negative 6 is negative 9. Negative 9 times negative 3 is 27. Negative 18 plus 27 is 9. 9 times negative 3 is negative 27. And negative 8 plus negative 27 is negative 35. Therefore, 3 is not one of our zeros. Let's try positive 4. Bring down 2. 2 times 4 is 8. Negative 3 plus 8 is 5. 5 times 4 is 20. Negative 18 plus 20 is 2. 2 times 4 is 8. Negative 8 plus 8 is 0. Therefore, 4 is 0 of p of x. Now let's try 8. So, 8. Bring down 2. 2 times 8 is 16. 16 plus 5 is 21. 21 times 8 is 100. 168. 2 plus 168 is 170. Positive 8 is not a 0 of p of x. So let's try negative 8. Bring down 2. 2 times negative 8 is negative 16. 5 plus negative 16 is negative 11. Negative 11 times negative 8 is 88. 2 plus 88 is 90. Therefore, negative 8 is also not a 0 of p of x. So what are we gonna do if we have tried all of the possible zeros and still can't get another 0? Then, there must be a multiplicity. So, let's try positive 1, for example. Bring down 2. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1 is 7. 2 plus 7 is 9. Therefore, 1 is not the multiplicity. What about negative 2? So, I'll bring down 2. 2 times negative 2 is negative 4. 5 plus negative 4 is 1. 1 times negative 2 is negative 2. 2 plus negative 2 is 0. Therefore, negative 2 is the multiplicity of p of x. Now that we only have 3 numbers as our answer, we might as well turn this into a factored form to save time in finding the next 0 by multiplying x to the first number. So, positive 2 times x is positive 2x. Therefore, our factored form is 2x plus 1. By transposing our factored form, we'll find our 0. So, 2x plus 1 is equal to 0. We will transpose positive 1, therefore 2x is equal to negative 1. And 2x is equal to negative 1 is not a valid answer. Therefore, we must divide both of them by 2 in order to isolate x. So, we will cancel out both of the 2. Therefore, our answer is x is equal to negative 1 half. Now, all of our possible zeros are now positive 1, 2, negative 2, multiplicity of 2, positive 4, and negative 1 half.
Good day, students. I'm Miss Malani, and I'm going to teach you guys how to find the zeros if the given is a quintic equation. Now, what we have as an example here is p of x equals x raised to 5 minus 5x cubed minus 15x squared plus 3x raised to 4 plus 4x plus 12. What we're going to do first is, of course, put it in its standard form. Its standard form is going to be x raised to 5 plus 3x raised to 4 minus 5x cubed minus 15x squared plus 4x plus 12. There we go. Now, what we need to do next is to find the possible zeros. So, how do we find the possible zeros? Well, it's going to be easy. We, of course, use the formula p over q. Our p is the last digit, or the digit that is the whole number. And our q is the one with the highest degree, the number that has the highest degree, not the highest degree, the number with the highest degree. So, it's going to be 12 over 1. Again, x is 1. Now, we find the factors of each of the number in the fraction, and the factors would always be positive, negative, since positive times positive is going to be positive, and negative times negative is still going to be positive. So either way, the answer would still be the same. So it's going to be positive, negative. Oh, the factors of 12 is positive, negative 1, positive, negative 2, positive, negative 3, positive, negative 4, positive, negative 6, and positive, negative 12. There we go. Now, this one is quite easy. The factors of 1 is, of course, 1, so positive, negative 1. What we do now is divide the denominator to the numerator. Now, divide positive, negative 1 with positive, negative 1, and divide the rest of the numbers with positive, negative 1. You would still get the same number. So, we're just going to copy what's at the numerator. So, our possible zeros will be positive, negative 1, positive, negative 2, positive, negative 3, positive, negative 4, positive, negative 6, and positive, negative 12. There we go. Then, since we already have our possible zeros, we can now start with our synthetic. It's going to be inside the synthetic is this one, our standard form. So 1, 3, -5, -15, 4, and 12. There. So what usually comes to my mind when I hear 12 is 2 for some reason. So for my technique, I would like you to think about the number that usually pops up in your mind whenever you hear that certain number. So in this case, think about 12. What usually pops up in your mind when it comes to 12? What usually can you multiply with a number to get 12? For me, I thought of the number 2, so we're going to be trying 2 here. 2 is already in the possible zero, so we can use that. Bring down 1. 2 times 1 is 2. So 3 plus 2 is 5. 5 times 2 is going to be 10. -5 plus 10 is going to be 5. 5 times 2 is going to be 10. -15 plus 10 is going to be 5. -5. -5 times 2 is going to be 10. So -10. 4 plus -10 is going to be -6. And -6 times 2 is going to be -12. So 12 plus -12 is 0. So it's going to be 0. We already have our first zero, which is 2. Now, zeros. I'm going to write that down. 2. Think of another number, or think of a number that usually comes up when you hear the word, or when you hear the number -6. What usually pops up in my mind is, of course, -2 or 3. So we're going to be trying -2. I'm going to delete this. Oops. Bring down 1. -2 times 1 is going to be -2. 5 plus -2 is going to be 3. -2 times 3 is going to be -6. 5 plus -6 is going to be -1. -1. -1 times 2 is going to be -2. Or positive 2, I'm sorry, positive 2. -5 plus 2 is going to be -3. -3 times 2 is going to be positive 6 is 0. Again, we do the same technique for -3. Our second zero is, again, -2. There. Next is, when you hear that -3 number, what usually pops up in your mind? Well, what usually pops up in my mind is, of course, -3. So let's try that. Bring down 1. -3 times 1 is -3. 3 plus -3 is going to be 0. 0 times -3 is 0. Bring down -1, since -1 plus 0 is going to be -1. -1 times -3 is going to be positive 3. So -3 plus positive 3 is going to be 0. Now we have 3 numbers left. Again, what usually pops up in your mind when you hear 1? Well, of course, it's either -1 or positive 1. So let's try positive 1, since there. So bring down 1 again. 1 times 1 is going to be 1. 0 plus 1 is going to be 1. So bring down 1. 1 times 1 is going to be 1. -1 plus 1 is going to be 0. So that's the answer. So 1. So how do we find our last zero? Well, if you look closely at the bottom here, you would see there are two numbers, 1, 1, and 1, and the other one is also 1. Well, the other one is a symbol of x. Since when it comes to factored versions of this one, factored version of our zeros, we usually differentiate the signs. So if the number, if there's a given number here, the synthetic division is a positive, when it comes to turning it to a factored version of itself, we're going to turn it to a negative. So in this case, x raised to 2, x minus 2 for this one, x minus 2, x plus 2 for this one, we're going to change its sign, x plus 3 for this one, and of course, x minus 1 for this one, and x plus 1 for this. We're not gonna change its sign anymore since it's technically in its factored version already. In its factored version already. So, since we already have our factored versions, we can now easily identify the zeros. So, as stated earlier, we've listed out the zeros we've written here, adding the other one, which is -1, since we are changing its sign. -1. So, to simplify it, we're going to be putting, instead of 2 and -2, we're going to be putting positive -2. And instead of 1 and -1, we're going to be putting positive -1 and -3. So, these are our zeros. That is all for my lesson today. I hope you guys learned a thing, and see you again next time. Bye!
Now, here's where the fun continues. We prepared some additional polynomial equations for you to solve. Scan this QR code or visit this link to access some additional polynomial equations. Test your skills and don't forget to share your scores in the comment section below. And that's all, lovely students. Remember, just like these equations, life has its ups and downs. But with a positive mindset and the right tools, we can solve anything that comes our way. If you found this tutorial helpful, share it with friends or family members who might need a math boost for some mathematic insight. Until next time, stay safe, stay curious, and happy studying!